All right, so we're going to finish up the 10.3 notes starting on page 20. And what we're going to look at today really is going to bring everything in this chapter all together. The right triangle trig from the beginning with sine, cosine, tangent with the opposite adjacent hypotenuse. The 30, 60, 90 right triangles and 45, 45, 90 right triangles. The angles in standard position, the positive angles, the negative angles, the degrees, the radians, the alternate definitions of our trig functions with x, y, and r. Everything's going to come together in these problems. And for everything that we're going to take a look at, this is all going to be done without a calculator. So if you just give answers in the homework, that's not going to count for credit. I don't want you just typing these into the calculator. I want you going through the calculations that I'm about to show you. The first thing I want to do is I want to evaluate the sine of 30 degrees. And I want to see what the calculator is actually doing when it comes up with the number that it gives us. Where are these things coming from? Here's our process. Step number 1. First thing we're going to do is we're going to draw our angle in standard position. Draw the angle in standard position. The first thing that we need to do is draw our angle in standard position. So I'm going to put some little axes over here. I know that 30 degrees is just a spin over to here, so I'm going to do something like this. I'm going to mark that as 30 degrees. I'll go a little higher with that. And I've got my angle. Second thing I'm going to do, I'm going to draw in a right angle. I'm going to draw in a right triangle formed by that terminal ray and the x-axis. Draw in a right triangle formed by the terminal ray and the x-axis. So I'm going to draw in something like this, and I've got a right triangle now. Number 3. I'm going to go and I'm going to fill in all my angles, and now all of the angles we're going to be dealing with for evaluating our sines, cosines, tangents, we're going to say they're on the unit circle. The unit circle, remember, is that circle with a radius of 1. That's where the name unit circle comes from, unit 1. So I'm also going to fill in a radius of 1. Step number 3, I'm going to fill in the angles and a radius of 1. If this is 30, that's 90. I know this angle up there is 60. No, it's not a coincidence that I've got a 30, 60, 90 right triangle over here. And I know that what's across from the radius is 1. Step number 4. I am going to use 30, 60, 90, or in some cases, 45, 45, 90 triangles to find all the sides. And we're going to give exact answers for those sides, making use of roots when necessary. Well, okay, let's see here. Hopefully you remember from the first day of this unit, or actually the second day of this unit, what's across from 30 is x, what's across from 60 is x root 3, what's across from 90 is 2x. Okay, well, if 1 equals 2x, I know that x is going to end up equaling a half. So I'm going to fill in a half over here, and a half root 3, oh, that looks messy. How about I call it root 3 over 2, down there. Step number 5. I'm going to use the sides of my triangle to find the x, y coordinates of that point on my terminal ray, of that point over here, paying close attention to the signs, the positives and the negatives, just like we did in the last video. Use the sides of the triangle to find the x comma y coordinates of the point on our terminal ray paying close attention to the signs. So I need to find the coordinates of this point over here. Well, horizontally, I went over root 3 over 2. Vertically, I went up a half. Both are positive because I'm in quadrant 1, but if I was in a different quadrant, I'd have some different combinations of positives and negatives there. And I'm almost there. This is what I meant, though, when I said there's a lot of stuff that goes into these problems. Although I do promise you, once we get into this stuff, it's going to go a lot faster than this first example is going. Number 6, I'm going to evaluate the expression using our x, y, and r definitions. Looking for the sine of 30 degrees. According to what we saw in the last video, that's the y-coordinate over the radius. What's my y-coordinate here? It's half. What's the radius? 1. Half divided by 1? 1/2. The sine of 30 degrees is 1/2. I'm going to start by drawing out my angle. I'll then make a right triangle between that terminal ray and the x-axis. I will fill in all my angles, and I'll fill in the radius of 1. I'm then going to find all the sides using what I know about 30, 60, 90, or 45, 45, 90 right triangles. I'm then going to use the sides to get me some coordinates of this point over here, paying close attention to if these coordinates should be positive or negative. Finally, I'll go and evaluate the expression I was originally asked for using my x, y, and r definitions of these trig functions. All we're going to do for the rest of this video is just see a bunch of examples and then a couple different variations on how this stuff works. We're on page 21 in the notes, and of course, please feel free to pause things if this is going a little too fast and get caught up. Cosine of pi over 4. Well, I know that pi over 4 is the same as 45 degrees. So how about I just turn this problem into the cosine of 45 degrees? It's going to be a little bit easier for us to think about degrees when I draw these things out. Although for other things you're going to see next year in pre-calc, radians will make a lot more sense. I need to go draw 45-degree angles. So 45-degree angle is going to look like this. That's my terminal ray, 45. And my next step is to make a right triangle with the x-axis. So I'm going to draw this in over here, 90 degrees over there. I need to fill in the missing angle. Well, if that's 45, that one over there has to be 45. And I'll fill in my hypotenuse of 1. I now need to find the sides, and in this one I'm not going to use 30, 60, 90 right triangles. I'm going to use 45, 45, 90 right triangles. I know what's across from 45 is x. What's across from this 45 is also x. And what's across from 90 is x root 2. So I'm going to write out a little equation. X root 2 equals 1. Divide and divide. X is going to equal 1 over root 2. I'm going to rationalize, multiply by root 2 over root 2. I'm going to get root 2 over 2. That's this side, because that's x. And that's this side, root 2 over 2. I now need to put some coordinates on this point up here. Well, my x-coordinate is root 2 over 2, and my y-coordinate is root 2 over 2. If I want to find the cosine of 45 degrees, that means I need to do my x-coordinate over my radius. Well, my x-coordinate here is root 2 over 2. My radius is 1, so root 2 over 2 over 1 is root 2 over 2. And I've got the cosine of 45 degrees. They're now going to get a little bit more involved when we deal with angles that are not in the first quadrant. But the good news is our process is going to be the same. I want to find the sine of 240 degrees. And I'm going to start by drawing in 240 degrees. Let's see, 0, 90, 180. I know from what I know about the unit circle that it's the angle over here that's just short of vertical. So that's going to be 240 degrees. And I'm going to make a right triangle with the x-axis. So it's going to look like that. Now, if this whole thing is 240 degrees, and I know that from the positive x-axis to the negative x-axis is 180 degrees, how many more degrees do I go to get from 180 to 240? Well, 60, which means this angle up here is 60 degrees, which also means 30, 60, 90. The angle down here is going to be 30 degrees. I'm going to fill in my radius of 1. My radius is always 1. And then I'll fill in a couple things over here. I've got my x root 3, my 2x. You know what? This is the same equation solving I had on the other page. X is going to equal a half. So this side is a half. This side is root 3 over 2. You know what? This is always going to be the case. So maybe I don't even have to go through all that algebra to find the sides. I can just sort of use what I saw on page 20 and in letter A to very quickly find my sides. Here's what I mean. We're going to take a little break from problem B. If I have a 30, 60, 90 right triangle on my unit circle and the hypotenuse is 1, then I know what's across from 30 is a half and what's across from 60 is root 3 over 2. And if I have a 45, 45, 90 right triangle, like we saw in letter A, and that hypotenuse is 1, then the sides across from the 45s are going to be root 2 over 2. That's going to save me a little bit of work. So now I need to get some coordinates. Well, the coordinates of this point over here, I'm moving to the left and I'm moving down. I'm moving to the left a half, so my x-coordinate's negative a half. I'm moving down root 3 over 2, so my y-coordinate is negative root 3 over 2. Okay, well, I need to find the sine of 240 degrees. Sine of 240 degrees is my y over my r. My y is negative root 3 over 2. My r is 1. So the sine of 240 degrees is negative root 3 over 2. Next one. The sine of 315 degrees. Okay, well, 315 degrees. Let's see. I'm going to start here. I'm going to go over to here, the angle that's halfway through the fourth quadrant, like that. This is 315. Whoops, hold on. Sorry. I'm drawing my right triangle. If this angle is 315 and the whole angle is 360, to get from 315 to 360, you just have to add 45 degrees. So I know that has to be 45 degrees over there, which means I also know that this one's 45 degrees and my radius is 1. Well, from what I said at the top, from my calculations in part A, I know that if the hypotenuse is 1, both sides across from the 45 are root 2 over 2. So I'll fill those in. I'll fill in a root 2 over 2 and a root 2 over 2 over there. And now I need to give some coordinates. To get here, I moved right and I moved down. I moved right, root 2 over 2. I moved down, root 2 over 2, so negative root 2 over 2, and we have our coordinates. So I'm ready to go. The sine of 315 degrees is my y over my r, so negative root 2 over 2 over 1, or negative root 2 over 2. Next, the cosine of 2 pi over 3. Well, use what you know about the unit circle to turn cosine 2 pi over 3 into the cosine of 120 degrees. And you know what? See what you can do. Maybe pause the video and see what you can do here. I'm going to get moving on this. 120. There's my right triangle. From 120 to 180 is a difference of 60, so I know that has to be a 60-degree angle. And I know this has to be a 30-degree angle, and that side is 1. I know from that triangle on the top of the page what's across from 30 is a half, and what's across from 60 is root 3 over 2. I know my coordinates are going to be negative a half, comma, positive root 3 over 2. So the cosine of 120 is the x over the r. That's negative a half over 1. That's negative a half. Next. Haven't done any tangents yet, since they're going to be just a tiny bit different in our calculation, but the basic idea is going to be the same thing. Tangent of 7 pi over 4, I would rather think in degrees, so that's the same as saying the tangent of 315 degrees. So I'm going to draw this one out. 315 degrees will put me over there in quadrant 4. Make my right triangle and fill that in. I know that if this is 315 and all the way around is 360, how many more degrees would I go to get from 315 to 360? 45. 45 degrees over there. So I'm going to fill in those. Hypotenuse is 1. I know my sides are root 2 over 2. Actually, this is the exact same angle that I was dealing with in letter C. Root 2 over 2 in all those places. My coordinates are going to be root 2 over 2, comma negative root 2 over 2. I need to figure out the tangent of 7 pi over 4, which means I need to do the y-coordinate over the x-coordinate. Well, my y-coordinate is negative root 2 over 2, and my x-coordinate is root 2 over 2. Hopefully you see what's going on here. Same number on the top and number on the bottom, they're going to cancel. But if you don't, I could say negative root 2 over 2 times, how do you divide? You multiply by the reciprocal, times 2 over root 2. I'm getting negative 2 root 2 over 2 root 2. Everything cancels except the negative. So you're going to get a negative 1 out of that. Let's take a look at the tangent of 150. I'm going to draw in 150 over here. That angle is 150 degrees. I'm going to make my right triangle like that. I know that this angle over here is 30 because to get from 150 to 180, you have to add 30. I know this angle is 60. So I can go and fill in my sides. Across from 30 is a half. Across from 60 is root 3 over 2. Sorry, hold on. We need to get our coordinates. Coordinates at that point. I'm moving left and I'm moving up. Negative root 3 over 2, comma 1/2. The tangent of 150 degrees will be my y-coordinate over my x-coordinate. A half over negative root 3 over 2. Here I can't do that trick of they just cancel. I actually have to go through and do the division, which again means multiplying by the reciprocal. I'm going to say times negative 2 over root 3. I'll multiply and get negative 2 over 2 root 3. They cancel. So negative 1 over root 3. Oh, but what do you know? No roots in the denominator. We'll rationalize. Oh, that'll be fun. And we're going to get negative root 3 over 3. The tangent of 150 degrees is negative root 3 over 3. I definitely think that these are some of the tougher things we've done in Algebra 2, just because there's so much that goes into these and so much attention to detail that we need to pay. Next page. These are going to be a little different. Sine of pi over 2. Well, pi over 2 is 90 degrees. 90 degrees is straight up like this. And I actually can't make a right triangle with the x-axis, with the right angle being between like the x-axis and something else. But it's actually going to be a little bit easier to deal with this. Watch what happens when our angle is right on an axis. Sine of pi over 2, well, I know that the length of this side is 1. So what are the coordinates up here? Well, I haven't moved over. I've just moved up. My coordinates are 0, 1. I want to figure out the sine of pi over 2. That means my y over my r. Y is 1, r is 1. Sine of pi over 2 is just 1. Let me show you a couple more of these. Cosine of 3 pi over 2. Well, I know 3 pi over 2 is pointing straight down. So cosine 3 pi over 2, the angle, that looks like this, the 3 pi over 2, or 270 degrees. Coordinates of this point are going to be 0, -1. Well, I want an x over an r. X coordinate is 0, my radius is 1 because it's always 1. I'm going to get 0 out of that. These are a little weird, but I actually think a whole lot easier than the angles that land in one of the quadrants because we're just going to use some combinations of zeros and ones to figure things out here. Sine of pi, sine of 90 degrees. No, it's not. Let's try that again. Sine of pi, that's the sine of 180 degrees. Okay. Well, that means I'm right over here, 180 degrees, a spin like that. My coordinates, -1, 0. The sine is my y over my r. Y is 0. R is 1 because it's always 1. Getting 0 there. See if you can do the tangent of pi over 2. Which is like the tangent of 90. I want the y over the r. No, I don't. I want the y over the x. So I'm going to get 1. Oh, ooh. Okay, well, let's see. I'm going to get 1 over 0. You can't do 1 divided by 0. If it was 0 over 1, we'd be okay, but it's not here. 1 divided by 0, you can't do that. We have to say this thing is undefined. We have a 0 in the denominator. It's undefined. I have 2 more variations to show you, 4 examples to take care of those, and then we'll be set. Some negative angles. Well, the sine of -5 pi over 6. I know that 5 pi over 6 is 150, so -5 pi over 6 is -150 degrees. I'm going to draw it out. Let's see, -150 degrees will put me over here. That's -150. Okay, well, I've got my right triangle. To get from -150 to -180 is 30 degrees, so I'm going to put a 30 over there. I'll put a 60 over there. My hypotenuse is 1. What's across from 30 is a half. What's across from 60 is √3 over 2. Coordinates over here, -√3 over 2, -1/2. Sine is the y over the r. So I'm going to do -1/2 over 1, or -1/2. See if you can do the tangent of -120 degrees. Maybe pause the video, see what you can do while I get started. So I drew in my negative 120. To get from there to negative 180 is another 60 degrees, so I'll fill in a 60 there. Other angles of 30, radius is 1. I know what's across from 30 is a half, what's across from 60 is root 3 over 2. So I've got negative a half comma negative root 3 over 2. I want my y over my x, that's negative root 3 over 2 over negative a half. Well, I've got to do a little bit of work now. I'm going to multiply by my reciprocal, negative root 3 over 2 times negative 2 over 1, gives me 2 root 3 over 2, or root 3. Finally, angles that are bigger than 2 pi or less than negative 2 pi or bigger than 360 degrees or less than negative 360 degrees. What we need to do, we need to go find a coterminal angle. See what I mean by this really pulls absolutely everything we've done together? Find a coterminal angle. That means either adding or subtracting some multiple of 2 pi. In this case, rather than using 2 pi over 1, I'm going to use 12 pi over 6. And I'm going to get the cosine of pi over 6, or the cosine of 30 degrees, which is now something I can deal with. The reason I'm allowed to do this, by the way, 30 degrees is this angle that starts here and goes there. 13 pi over 6 is the angle that starts here, goes all the way around, and still ends up over there. We're still getting a point in the same final position. So it doesn't matter that I'm using a coterminal angle rather than the original angle. What's the missing angle is 60. This side is 1, a half, root 3 over 2. Coordinates are root 3 over 2, comma 1 half. My cosine is my x over my r. So root 3 over 2 over 1, you're going to get root 3 over 2. Last one, sine of 495 degrees. I'm going to go and I'm going to subtract 360 to get a good coterminal angle out of this. Let's see, that gives me the sine of 135 degrees. 135 is the angle over here. To get from 135 to 180, I need another 45 degrees. So I'll fill that in as 45 and that in as 45. 1, root 2 over 2, root 2 over 2. Coordinates are negative root 2 over 2, comma root 2 over 2. The sine is the y over the r. Y is root 2 over 2. The r is 1, root 2 over 2. I realize there's one more page in the notes. We already kind of talked about that last page, so if you want to just stop the video here, you're welcome to do that. If you're one of those people who will be a little bit bothered by the fact that there's a page of notes that we will not have done, I might as well go fill in that last page, but if you don't want to do this, you'll be fine with doing the homework based on what we've done so far. If you do want to just actually finish this off, let's take a couple of quick notes on page 23. Trig functions of what we call quadrantal angles. A quadrantal angle is an angle in standard position whose terminal ray lies on an axis. So an angle like 0 degrees, 90 degrees, 180, 270, 360, something like that. A quadrantal angle is an angle in standard position whose terminal ray lies on an axis. Like 0, like pi over 2, like pi. You can't see that. Like 3 pi over 2. Well, if I'm on this unit circle with a radius of 1, I'm going to go and just find the coordinates of these 4 points quickly. 0 has coordinates, 0 has coordinates 1, 0. Pi over 2 has coordinates 0, 1. Pi has coordinates negative 1, 0. 3 pi over 2 has coordinates 0, negative 1. This is particularly important for some of the graphing stuff that we're not going to get into. I know I referred a couple times during the year when we were actually in person to graphs that kind of bounced like this. Well, what we're looking at right now is kind of related to that. If you take pre-calc next year, you'll learn all about that stuff. But what I can do with these coordinates filled in is very, very, very quickly figure out these things over here. If I want to find the sine of pi is my y over my r. When you're at pi, what's the y? 0. What's the radius? 1. 0 over 1? 0. Tangent of 3 pi over 2. That's my y over my x. At 3 pi over 2, I've got negative 1 over 0. You already saw one like that. That's undefined. See if you can quickly do those last two. Cosine of 2 pi is x over r. 1 over 1, that's 1. Sine of pi over 2, that's y over r. That's 1 over 1. That's also 1. And this brings us to the end of the notes, and this brings us to the end of Algebra 2. You have either 1 or 2 more homework assignments you're going to do just based on this stuff, but otherwise we made it one way or another. Although this was a kind of weird last couple of months, here we are. I think that's about all I have to say. Take care.